Hello learners.
You can see an example here.
So the data in this table shows the number of miles traveled, the number of deliveries and the total travel time of 10 driving assignments of a trucking company. You can see in the table the first column is for miles traveled and the second column is the number of deliveries and the third column is for travel times. Now we have to determine an estimated regression equation on travel times given the number of miles traveled and number of deliveries. So here the dependent variable is travel times and independent variables are number of miles traveled and number of deliveries. So after estimating or fitting the regression equation, we have to interpret the model. Then we have to comment on the goodness of fit of the model, and finally we have to predict the travel time for some values of the number of miles traveled and deliveries.
So you can use R, Python or any other softwares to calculate or estimate the parameters of the model. I am using R programming here. So you can see the output from R in this
table here. So you can see that here we have many informations in this output. So all these informations are not needed for estimating our regression equation. So we are needed the values of only. We are needed the values of B0, B1, B2, these parameter values or these estimates of parameters for fitting our multiple linear regression line. Okay, so as we have two independent variables here, so we have two regression coefficients B1 and B2 here. You can see that here the coefficients and the estimate of the coefficients. Okay, so the first term is intercept, which is actually B0. Intercept is B0, which is, and the value of B0 is minus 0.868701. And for the variable x1, the estimate is 0.061135, which is the value of B1 actually. And for the variable x2, the value of estimate is 0.923425, which is the value of B2. Okay, and the value of R square is 0.9038 and adjusted R square is 0.8763. The value of R square and adjusted R square is close here. So we will need only these highlighted values for interpreting our model or for commenting on goodness of fit. As we have the values of B1, B2 and B0, so we can fit our regression line. So recall the estimated multiple regression equation, which was y hat equals to B0 plus B1 x1 B2 x2. So this model is for two explanatory variables, as we have two explanatory variables or two independent variables in our problem. So now we have the values of B0, B1 and B2. So we have to put the values in this equation and we will get the estimated multiple regression equation, which is y hat equals to minus 0.869 plus 0.061 x1 plus 0.923 into x2. This is the value of B0, this is the value of B1 and this is the value of B2. Now we have to interpret the regression equation or the regression model. So the value of B0 equals to minus 0.869 means that the travel time will be minus 0.869 when the number of miles traveled and the number of deliveries are 0. B1 equal to 0.061 means that the average travel time will increase by 0.061 unit when the number of miles traveled will increase by 1 unit, keeping the number of deliveries fixed. And we have the value of B2 equals to 0.923, which means that the average travel time will increase by 0.923 unit when the number of deliveries will increase by 1 unit, keeping number of miles traveled fixed. So here we are keeping one variable or one explanatory variable fixed. Now we will comment on the goodness fit of the model. So the value of R square is equal to 0.9038, which means 90.38% of variation in total travel times can be explained by the variables number of miles traveled and the number of deliveries. And from adjusted R square, we see that the value of adjusted R square is 0.8763, which means 87.63% variation in total travel times can be explained by the variables number of miles traveled and the number of deliveries. We can see that the value of R square and adjusted R square is quite large here, so this model provides a good fit. Now I will predict the travel time for 85 miles traveled and 5 deliveries. Now what we have to do, or what I have to do, that I have to just put these values 85 miles and 5 deliveries in the estimated regression equation. And this is the value of x1 for x1 and this is the value for x2. I will put these values on the estimated regression equation, and after calculating it I will get my predicted travel time. So which is y hat equals to minus 0.869. This was the value of b0 plus 0.061. This is the value of b1, and I multiplied it by 85, which is the value of x1, and plus 0.923 into 5 equals to 8.931. So the predicted travel time is approximately 8.9 minutes for 85 miles traveled and 5 deliveries.